Okay. Okay, so we wait for people to come in, maybe a few more minutes. Okay, I'll switch on the attendance sheet for you. Okay, yeah. Attendance sheets. Okay. Okay, so I'll wait for you to take your attendance, maybe 1 or 2 minutes. Okay, so for some reasons I have to admit people who just log in, so I cannot allow you to log in automatically. I do not know how, so it could interrupt our class if people are coming in. So I have to click on the icon to allow them to come in. So how are you? You're doing well. Just for information, I realized that the test that's scheduled this Friday cannot be done. Because this Friday is the 1st of May. So 1st of May is a public holiday. So we have to postpone the test until next Monday. Okay, so we have 2 tests. Either we conduct 1 test next Monday and then have to find a way to conduct another test. Then I have to assign you a project to do. Okay, so I think everyone will be doing different projects. There are about 34 of you, so I have to think of many different projects so that you would be able to do a different project on your own. Okay. So any questions about this? We have a project, small projects. You will take about a few more weeks to do, and then you have assignment, and then you also have a test. Okay. So the test will be done online. Now the problem is that if you conduct a test online, then from my point of view, I would not know whether you are doing it yourself or whether you are copying from friends. So what I can do is that I'll check on your solutions. Now, if your program are exactly the same as your friends, I'll take that as a cheating. Okay, so this is what I can do lah. If you submit your assignment and if it's more or less the same, then I'll just let you through. But for your test, you can't. For test, you have to submit your test, and then you have to make sure that your test is different than your friends. The solutions must not be the same. What part will be covered in test 1? If you look at the Moodle, the learning our portal, you go to see the announcement. So in announcement, I just made some descriptions here. So this is the question we are going to talk about. The first test, this is the one. So do you see on the screen? The first test is to be conducted and submitted online. Questions will be on everything that has been taught in the lecture. If you can do all the assignment, you should be able to do the test. Okay. So I would like to give simple tests this time instead of giving you a very difficult test. I think people who have to work online may be struggling with a lot of trouble. So instead of making your life difficult, I would like to give only simple tests lah. So you should be able to finish it within 1 hour, and you'll make sure that you don't copy from your friends. So that is the only thing I want to beg you. So as a compromise, what I do is that I will not give you difficult tests. I'll give you simple tests so that you don't need to copy from your friends. Just submit whatever you are able to submit as a way to show that you have participated in the test. And I suppose that there are people who cannot attend the test because of the limitations of their computer or because of some problem. I'll try to find out a way to solve this problem. Now, any of your friends I think 1 or 2 have emailed as a send message to me saying that they have problem of accessing the online testing, the online test and also the online teaching. Now, any of you who have that problem, could you please send me messages on WhatsApp again? I'll see what we can do. We may have to make some special arrangement for you to do the test. Maybe we'll conduct the test for you, especially after the movement control or something else. But anyway, if you have problem with the hardware and software to access the test online, please make sure that you contact me. But if you do not contact me or your friends do not contact me, if you have this problem, that will consider as an absent. Okay, so just message me or write emails to me privately. Then I'll see what we can do about this. But definitely next week, Monday, we will have a test. Okay. So any questions at the moment? People are still coming in. Okay, fine. So we have 26% coming in. There are about a few more persons who are missing from the action. It's fine. So you can always refer to the uploaded video afterwards if you come in late, but you will consider as absent, okay, because you don't take attendance. Okay, we are going to look at a new topic today, which is on the integration. Okay, so you try to look into this. Let me go back to the to our web page. So the link to the new topic today is part 7. Okay, so the part 7 is a web page that is uploaded in this place called Jupyter Notebook Viewer. Okay, so in the Jupyter Notebook Viewer, you see this. You can download this as well. But I think there is some little problem is that I have made some update in the corrections. I've made some corrections to the content here in this Jupyter Notebook Viewer. Okay, but somehow after updated the files, the content on the Jupyter MB Viewer is not really updated. Maybe it takes some time to update. There's some error here and there, which I have replaced it. Wait, let me let people to come in. Okay, so, but these are only minor corrections, and hopefully that after maybe a few more minutes, the MB Viewer Jupyter will show you the latest versions. Now, all the files that you see on this Jupyter actually are linked to this web page. Let me show you where the web page is. Okay. I have a web page, which is this. Okay, so you can take a look at this. In our Moodle web page, there is a link to this resource called what? Called Anicca. Where is it? Jupyter sources in Anicca. So this is the, yeah. So this is the link to the server called Anicca. Is it linking? Yeah. Yep. So this is a place where I put the notes for the notes for the data. So the latest note is actually this one, part 7. So what I do is I copy this part 7 and then I paste it into the Jupyter Notebook page. So this is the Jupyter Notebook page. So what I do is just paste the link of Anicca into here. So that this MB Viewer Jupyter would access the file from Anicca server and display it here. But once the files in Anicca has been updated, this MB Viewer does not show the latest version. Somehow it saves it in the library, in the history file or something like that. But just to make you aware of the lag in the update versions of this. Okay. So never mind. You can still use the Jupyter files that you can link from here. So just click on this, and then we're going to do this part 7 today. So there's a lot of open files on my things here. So let me close off in case it's just messing up with my teaching. Okay. So let me close it, should I? Okay. Okay, let me show this. Okay, so we are looking at the part 7 of the course today. So today we are going to do something not very complicated, but it's something which is quite simple lah. Okay, let me see if I can do this fast. If it can be done fast, then you would not be so bored lah. Now this is a chapter on integrations. We are going to use the Python to do integrations. But before I proceed on, just to make sure aware that there are two types of integrations. Well, when I say two types of integration, I'm saying the integrations. Wait, let me try to adjust this height of this. Okay, it looks like it's better now. Okay, so there are two types of integration. Okay, when I say two types, I mean not really two types. If you are given a function, you can always integrate it, right? So in your ZCE 110, you are given a sum function and you are trying to integrate it analytically, right? So when you integrate these functions analytically, you are actually trying the what do you call the the indefinite integral. Right? The indefinite integrals is very similar to the what do you call antiderivative. Okay, so in 110 you learn how to perform the integrations analytically. But what you want is that if you are given a limit for integrations from say limit a to b, then finally what you obtain is what you call an definite integrations. Definite integration is a number. Now, once you are given a function, you integrate from one limit to another. Finally, what you get is a number. So, as long as you get the number, that is fine. That is what your purpose is. Given a function, integrate from one a to b. Tell me what is the values of the definite integration. In short, it is representing the what they call so when you're given the integrand, the fx here is an integrand, then integrate over from a to b, finally you get the definite integrations. So this is a number that you're looking for, and more or less this definite integrations represents the area under the curve of a function. Okay, so given a functions, you can easily obtain the definite integrations using Python called scipy.integrate. So this is a package. So scipy is the package that we are currently talking about. In scipy, there are many functions. One of the functions is integrate. So this integrate allows you to perform what we call a single variable integration. In all the functions that you learn in ZCE 110, you are dealing with a function of single variable. And your integration is what we call a single variable integrations. So you only integrate over one variables, right? So instead of integrating over two variables, you only integrate over one variables. If you go to higher level of mathematics, you would have encountered functions which is more than one single variable. It could be two variables, three variables, or maybe like n variables, and you have to integrate over n variables instead of only one. So that would make life much easier if you were to be asked to integrate over functions of many integral, a function of many variables. Okay, so it's very easy. In order to do integrations, you have to provide a few information. For example, you have to know what is the functions to be integrated. You have to tell me where is the limit of the integrations. Yeah, I think basically that is what you want. Okay, so you can easily do that by using science by integrate, which could be easily. So you have to also define the function. So let us do a very simple integration. Now you can actually find this here. Let me try to reproduce the code that is given here. Okay, it should be very simple. So first of all, let us integrate a function of x squared. So what you need to do is, for example, you have to define your function. You just call it f, okay? Then the function admits an independent variable called fx, and then you just have to define it, x squared, for example. This is x squared. So that is how you define a function. Then, in order to integrate a function, you have to import, okay? Import size by, and then dot integrate. I think integrate. Okay. Let me admit people come in first. Where is it? Okay. Okay, so Zizang is admitted. Okay, so that's how you call the size by integrate. So then once you have called the size by integrate, then you just say I want to integrate. Now integrate what? Integrate the level a from say -1 to 1. B is your upper limit of your integration. So you define the values of your integrations, and then you just say size by dot integrate. Okay. Then you say f. Then you just provide the lower limit and upper limit, and then see what you get. No, you get an error. What is an error? The error is function. Okay, so there is some trouble with this. Size by integrate f. The f is integrating f squared. So what problem is that? I do not know what's the problem. Let's try it again. Okay, so integrate f, a, and b, and then there's still a problem. Module object is not callable. So let's look at the correct answer. The correct answer is, quad. Now, this is wrong because the error comes from the fact that integrate itself is a big package. Okay, so in order to make things easier, let me take a look at this. So always try to type help to find what is integrate. Okay, so this is how the help integrate. Okay, help integrate size by integrate size by dot integrate. So size by integrate tells you what is the size by integrate function. So it has a lot of options. So you have to choose among many different methods to perform the integration inside the integrate package. So integrate is a big package. So you have to further specialize. So you have to further specify what method you want to use in order to perform the numerical integration for the integrand. So this function fx which you want to integrate over is called the integrand. Right, so to perform an integrand, which is made up of a function or a single variable, you have to choose one particular method, right? So you can choose quad, double quad, triple quad, n quad, fixed quad, quadrature, rhomboid. But I think what you need is not all this. Okay, I think some of these may not be suitable. Some of these methods may not be very suitable. But the general purpose is to use a quad, QEAD. I think QEAD quad stands for quadrature. Is a specific numerical method to perform integrations, and it works for most of those functions that are continuous. Now, last time when we were teaching this ZCE 111 class, we also learned to write our numerical code. Instead of calling the package from Mathematica, you can write your own code, but you have to know what are the numerical tricks that is used to perform integration. Okay, so there are many different methods. Quad is one of the most common methods. You can also use trapezoid rule. You can use also whatever rule that is suitable. But I think quad is the default method that is used. Now, for example, if you look at rhombic integrations, or you look at, say, I think Newton codes. Now, these are more efficient and more sophisticated method for performing integrations. It does not calculate really the total area under the curve, but it evaluates the integrations by using weightage, right? So those function that is more, those area in the function which is more important will be sampled more, while those functions, those values in the regions where it is less important will be sampled less. So this Romberg or the Newton codes are sophisticated integration method purposely meant only for integrating functions which are very bumpy and discontinuous. So there are functions which is very complicated, right? So it's not smooth like the sine function, but maybe those functions are very sharp and very complicated, like they have most of the time it's more flat, but only at some particular region the function just drops or just rise. So for this kind of complicated functions where the profile of the function is not smooth, then only you would use other complicated other method. But for most of the functions that are smooth, you just have to choose the quadrature method. So we are going to talk about only two methods here today, quad and double quad. Now double quad is meant for double integration. So today we are going to learn how to perform integration numerically for a function of single variables using quad. Later on we are also going to learn how to use integrations for performing double integrations where we apply it to function of two variables. So you have to specify what are the methods you have to use, okay? So SciSpy is not working. You have to say integrate dot what method. So you just have to say quadratic method, okay? And then you have to specify what is the integrand. So just have to supply the integrand. Then that's it. Okay, so that is the results. So you find that the result is 1 over 2 over 3. Right, this is 2 over 3. So you find that the output from the integrate sine squared contain two components. So that is the results. Result RUS. So the result is this. The first component of the result is RES 0. It is a result, numerical result that we are looking for. Now what is this? The second component in the SciSpy output is the error. Right? So this is a numerical error. All the functions that are integrated numerically in computers always have an associated error. So the error in practice could be small. So sometimes, in most of the time, we just ignore it. But for very complicated numerical integration where we need very high accuracy, then you have to take care especially for the error. So you have to choose method that would result in small error. That is always the case. And sometimes not only that, you have to make sure that the scaling of the error is behaving properly as you wish. For example, for some method, the error scale as delta power n, some scale as power n minus 1. So if it scales with the delta, where the delta is the width of your intervals. So if the width of the intervals is getting smaller, then the error should go smaller. Okay, so the behavior of the error are different in different methods. Okay, but we are not really care too much about the error. We just always practically assume that the error is acceptable. Okay, so for example, in this case, the error is as small as 10 to the power 15. So definitely is sufficient for most of the practical purpose. When you integrate some function, you just get a number, and the number is like this, 0.66666, right? So it's fine. The error can always be ignored. Okay, so this is a very simple way of performing integration. Now you can perform a much more complicated functions. But usually what we do is that before you perform integration, you want to see the functions, right? So for example, let us try to perform another integrations for a more complicated one, which is not a sine, we should say a cos. So let us try to say a cos function. If you were to use a cos function, you have to use numpy. Okay, let me use it here. So let me import numpy as np, And then let me show that we are using, say, cos function. And then when you integrate the cos functions, then your limit will be, say, minus np dot pi, and then you go to np pi. So you integrate the functions of cos. The cos is a function that most of you should have familiar with. Is a very common periodic functions, trigonometric functions. You integrate from minus 180 degrees to plus 180 degrees. So in ZCE 111, we introduce very thoroughly the behaviors of the cos function. So you should be able to understand what would be the output when you integrate the cos function. So it should be 0. Okay, so you integrate this, then you got the answer. Then let's look at the answer. So the answer is 2.6 to the power of minus 16. It means that it's 0. Okay, so if you were to integrate a cos function and a sine function, say if you integrate also add with the sine function, so what do you get? Now you also get a 0, right? So because if it's a sine function, it's also a 0. So if you take away the cos, only sine, you also get a 0. But in this case, the 0 is exact. If you add with cos also, it becomes 0. What I'm trying to tell you is that whenever you perform an integration of a function, you don't just take the results as it is. You make sure that it makes sense to you. So normally what we do is you always want to print a function. See with your own eye how the function is visualized over the range of integrations. Only then you accept your numerical result. Right? This is what I keep on doing. Whenever I get a number from the numerical result, we always want to check and make sure that it makes sense. Okay, so one really simple way to make sense is to plot the functions. So let's just plot the function for x that is ranging from a to b. So let's just make a x to b equals to np range, well, maybe linear space. Np linear space from x1 to x2, and maybe we put 20, 25 intervals between x1 and x2. Then so this is my x. Okay, so the x is a array that looks like this. Now once you have the array, then you can easily print the functions of x, right? So what is fx? Fx is like this. So when I print out, I expect to see another array, right? So this is an array for fx. So now I am in the position to plot, right? Plt dot plot the function of x and x. So plt is this. So I have to, in order to use plt, I have to import matplotlib, right? Matplotlib dot pyplot as plt. So in the beginning of this course, in the first few lectures, we use the built-in pylab functions, but I find out that the pylab function that was introduced in the first few lectures are not as useful. So we should now migrate to use exclusively the plot functions that is provided by matplotlib pyplot, right? So we have to use this pyplot very, very often. So then you have this. You say, okay, I'm going to use the plot plt function for matplotlib to plot the function f. So it looks like this. Okay. So it looks like this. It's a function from x1 to x2. x1 is minus pi, not x1. Okay, x1 is wrong. Okay, this is not x1. It should be a and b. Okay, so a and b. So it looks much better now. So you have minus pi to pi, and this is a 0, right? So you look at it. It looks like is it making sense? Sine and cos. Okay, so somehow there is a 0 across here, and then the integration should be 0. Yeah, I think it's right. So if you look at this somewhere here, the graph is symmetric, and then the integrations above the y positive and below the y 0 should cancel off. Okay, so the functions give you a values which is okay. So let me print this out. Print, and then I got a 0 value. Okay, so maybe I can do a different job by saying squaring it. I just want to see that whatever I do, I got a correct answer. Right? So when you square it, the function is always above 0. So when you integrate over the function above 0, you should get a positive number, and a large positive number. And the result you got is 6 point something. So this is in accordance to my expectation. Okay, so there's no problem to perform integrations. But let us look at the more complicated situations. The more complicated situations where the functions is not just a function of integrations. Let us look at this example of a special functions. The special function is a function, it's a type of function that is encountered very often in physics. Now, if you are not doing physics, you are doing, say, don't know what, say history or whatever, you don't need to deal with special function. But if you are doing physics course, especially for those theoretical physics, when you study quantum mechanics, when you study statistical mechanics, when you study electrodynamics, very often you encounter these special functions. Now, this special function would look like this. For example, an example would be the Bessel function, right? So this is a Bessel function. Now, there is a host of special functions. So you can look at, if you click on this one, you would be brought to the page of SciSpi. So in SciSpi, there is a whole list of special functions which is defined for you. Remember the function that we were talking about in part 6.2, where there's this gamma function, remember? Gamma function. So I think there is a gamma function that is also described here as well. Gamma, let me see, find GMMA. Yeah, so no, there's no gamma function here. Gamma function. There's a lot of gamma function. Yeah, okay. So here, there's this gamma function, which is also provided in the SciSpi special function. So we are going to talk about the package called SciSpi.special. So today, we have talked about SciSpi.integrate.quad. And here we are going to also mention this SciSpi.special. It's a package where it contains a lot of special function, which is often encountered in the studies of engineering and physics. Now, these functions sometimes could be very complicated, but basically it's just a function, right? So, for example, the Bessel function, if you click on the link to the Bessel function, this is the example. So maybe if you are using the correct versions, when you click on this, you should be landing on this page. Now, if you have a problem, just make sure that you throw away those whatever. So the functions should be Wikipedia, Bessel functions only. So maybe if there's an error in your link, just change the link a little bit. But the latest versions, error has been corrected. When you click on this, you should land on the Bessel function. So this link tells you what the Bessel function is and its definitions. But what we are going to do here is not really that difficult. We're not going to learn all the mathematical properties of the Bessel function. We just want to generate this Bessel function, and then we want to integrate it. Now, this is the definition of the Bessel function, right? So Bessel function is a function of x. It's just like the logarithmic function. Like in a sense, logarithmic functions is also a special function. It's a function that is described as an integral representation. So it's not a function of, say, x squared plus 2, but it is a function that's expressed in terms of an integration. Logarithmic function is an integration of 1 over t. Right? You integrate dt from 0 to x. So that gives you the logarithmic function. So the Bessel function is also kind of integral functions, where you have a function that looks like this. So just look at these functions. I just try to dissect for you. The function depends on the independent variable x. But this x of the Bessel function enters the definition of the Bessel function in the form of its integrand. Right? So you define the integrand then you integrate over the integrand. And the integrand is cos n tau minus x sine tau d tau. And this tau is the independent variable. Okay, so you have to integrate this d tau from 0 to pi. And then whatever values of the integral functions for the Bessel function, you have to specify the values. Like you have to specify x equals to 0, x equals to 1, x equals to 2. So you put in this value, then you obtain a values of j, n at that x. You also have to specify n. So in this case, n is an integer number. And I think in this case, the n in the Bessel function is called the order. So a Bessel function is specified by its order. So the Bessel function of order 0, Bessel function of order 1, Bessel function of order 2, evaluated at x equals to, say, 0.2, 0.4. So your job is to tell me how you would perform such integrations using the method that we use. Okay, so let us try to do this. It's not that difficult. So the Bessel function is integrated in this manner. And if you specify with different n, then the Bessel function at different x will be different, right? So if you plot the values of the Bessel function as a function of x, so you vary the x from 0 to 20, then you get this, right? So this is the Bessel function of order 0. Bessel function of order 1, Bessel function of order 2. Now, for those who are already gone through the class by Dr. Nohas Linda, I think last semester, you must have seen this Bessel function, if I'm not mistaken, or maybe 277 or something. One of the courses, mathematical physics, mathematical applications, or mathematical method for physics, definitely you will see this. Okay, you also see this in your quantum mechanics. Okay, so in order to obtain the functions that is shown here, you need to know how to perform the integrations. Once you have finished performing integration, you have to perform the integration for different values of x. X equals to 0, you have to get 1 point. X equals to 0.1, you have to get the values for j. So you have to keep on getting the values of the Bessel function at x values from 0 to 20 at some intervals. So then you connect all the values that you integrated at each point of x, then you join them up, you get this function. So each functions of the Bessel have to be specialized by different order as well. Okay, so let's see how you can do this to generate this. Now, before we write our code to generate this, okay, we can also generate the functions using the special functions. So we're going to do two things. First, we are going to generate the Bessel function using the SciSpi function. So we are going to use this, I think J Bessel, let me find it, B-E-S-S-E-L. So first, you can generate the Bessel functions from the SciSpi package. So the SciSpi.special allows you to generate the Bessel functions. So you have to know where to find it. This is the Bessel functions of the first kind of real order and complex arguments. So in this case, this is just the function that is described by this. Okay, it's called the Bessel function of the first kind. There are many different types of Bessel functions. So you could have Bessel function of exponential, whatever order, Bessel function of the second kind, third kind, blah, 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 blah. So these are all special functions. But for the purpose of this course, we are going to take the Bessel function of the first kind as an example. So you can generate the functions, Bessel functions of the first kind very easily by using this. But you have to specify what is the argument, what is the range of x you want to plot, and then what is the order, right? So this is how you do it. It says in order to plot the Bessel function, you just have to specify the v. The v here is the order. I think z is the argument. So the z here is just the values of x. Okay, the z is just the values of the x. Let me see, where am I? Okay, so the z is just the values of x that's specified here, and then mu is the order. So in order to get the Bessel function, for example, let us try to get this point. The Bessel function for the 0th order at x equals to 0. So how do you do that? It's very easy. You can just do it like this. First, you have to import. Right? So import SciSpi dot special. I think it's called special. Yeah. So in order to shortcut it, I call this import as SS so that I don't need to type whatever I need to call out function. I do not need to type scip.special. Just type SS. So SS is a shortcut name to represent size pi special. So I would look at this function. So in order to call the Bessel function is like this. So I click on this further. So it says in order to call the size pi Bessel function, this is how you do it. This is the parameter. V is the array and order, Z is argument. So you only need to specify what the V and what the Z or the argument is, right? So it's very simple. So I'm going to say ss.jv, right? And then I have to specify what is my order. The order appears as the first argument, V, and then only then you specify the independent variable of Z. So we are trying to get this point, right? So this is a point when Z equals to 0, and the order is n equals to 0. So this is 0. I will say 0 and 0. Okay, maybe I think it's possible to do it like this. So the n here represents my order, and x is the coordinate. So when I press a button, I should get 1. Do I get 1? No, the reason is because I think you cannot specify it like this. Okay, you have to specify it like this. Yeah, it's 0, it's 1. Now you can try to say some number, maybe which number? Maybe here. So for n equals to 2, 3, this green color dotted line, blue color dotted line. For the for the n equals to 1, n equals to 2 order, the values at x equals to 0 should be 0. So test if this is true. So for order 1, the value should be 0. Yes, it's 0. For order 2, the value is also 0. Okay, so now we are ready to plot the whole function for order 0. Let us try to plot the red color line first. So we're going to plot it from 0 to 20. So it's very simple, right? So if you know how to call out the values of this function, now it's so let's just like this. So you are going to specify your x, well, x init. You start off with 0 and then x last, which is the last value. So let me call this x init. X last is 20. Then we create an x coordinate, which is a linear space. So the linear space have to use import numpy as npi, and then this should be the numpy function. So this linear space will give me an array, and then let me say I generate this for say 25, maybe 50 point will be fine, right? So then I'm going to call out my size pi special function. Fv is the name of the Bessel function. Bessel function Fv, yeah, JV, sorry, I will keep on forgetting. So JV, order 0, well, maybe I say n here, and then I say x here. Now n is my order, n is the order of 0. So I specify the order as 0, and then I specify my x, where x is already defined as an array. So when I press the button, I expect to see this will give me an array of 20 numbers, which represent the values of the Bessel function of order 0. These are all the values of the j. Then now I'm ready to plot, right? I'm going to plot plt.plot the function of x and this one. Yeah, this is a function. It looks like it, is it? No, it doesn't look like. So we're looking at this kind of function that is varying from 1 to -4, and then it oscillates for a few times from 0 up to 20. So no, this is wrong because it's up to 2020.0 x last. So now this is wrong because I call this x1. This is called init. I change the values of x to become x. Instead of using x1, x2, I should use x initial and x last. So this would give me the function that looks like this. Okay, so it's green, blue color. So it looks like this. Like you start from 1 oscillates for 1 time, 2 times, 3 times. Right? So it oscillates for 1 time, 2 times, 3 times. So this is how you integrate, how you plot the function. Now let's try to reproduce 3 more graphs. Now how do you plot 3 more graphs in one? Combine 3 graphs in one. Okay, so that's the trick, right? So maybe I'll show you how. Now if you do it correctly, that is how you do it. Now you can combine many functions in one graph. You know how to do it. Now to generate one graph is very simple, like this, right? So in order to generate many graphs, how are you going to do it? So in that case, you have to change the variables of n, right? So we're going to make n to become a set of number. Say n is equals to 0, and say 2. Okay. So what do you do? So you make n to be an array. Well, maybe like this. So when you plot like this, you have one plot. Now, if you want to generate many plots, let us try to do this. So let us try to put this whole thing in an array, with a 4. Okay. So this is an array. Okay. When I do this, then I get an array. Now, if I do like this, I got 2 array, right? So let's say I set this n to be 0, and then I set the n to be 1. Then I got 2 values, 2 plots. Now if I have 3, then I have 3 plots, right? Okay, then this will become 3, right? Now, so we can actually generalize this to n, right? So what are the common in argument here is that this and this argument, they are all common except for the n, right? So let us try to generate this array of 3 elements using a 4. Okay, so how do you do that? It's very easy, right? So let's just see how you do it. I think I have demonstrated this once, but I don't mind doing it again. So here, let us try to generate 3 plots, where this plot varies for the n from 0 to 1 to 2, right? So just assign an n here, and then you say for n in 1. Well, in arrange. Now you want how many you want? 3, right? So this, sorry, not arrange, range. So the range would change from 0 to 1 to 2, right? So that would generate n equals to 0, n equals to 1, n equals to 2, n equals to 0, n equals to 1, and n equals to 2. So that would give you this, right? So what I'm saying here is that this array is equivalent to this array. Okay, so let me highlight this array. So whatever you see is coming from this array. Now, if you want to have, say, function like this, you have 0 up to 5, then you just change this to 6, right? So just change the range to 6. And you have all these function, which is 6 values, right? You can add also legends. I think you can add legends to this. You say, I think plt.legends, and then you will have legends plotted. Say legend. Now, in order to plot the legends, let me be a bit more careful. So let us try to do this. Okay. Now, I want to assign a legend. Now, how do I assign the legend? Now, before I assign a legend, let me explain to you how you do it. Now, if you were to do that, say if your n is just 1, there's only one n, say 0, that is how you plot, right? Now, in order to plot a legend for this, you just say plt dot legend. Now, I think you wouldn't have any legends plotted because you have not assigned the legend to this. So you have to assign the legend to this graph. So what you do is that in the plot here, just say label. I think you just say label equals to something. Now, to what? It's equals to 0. Right? So when you print it out, then you got the legend of 0. So now, if you understand this, then let us try to absorb this into the functions here. Now, so here you have to assign in the plot the label, right? Label. Now the label is what? Now there are different labels. So you have n equals to 1, 2, 3, 4, 5, 6, 7, 8. So if you have your label equals to n, will you get anything? No, you won't. The label has to be enclosed in an inverted comma, meaning that the values of n would appear as a string, but not a number. So if you do like that, then you wouldn't get the right thing. So when you plot the legends, you see it looks like all n, right? So what appears in your label is taken as just a string of n instead of a number that represents the order of n. So what you do, it's very easy, okay? So if you label this as n, I think it won't work, right? If you just do it like that, then it wouldn't work. It works. Well, it works. So it doesn't matter. But if you want to make things more complicated, I think the correct way how to do it is that you convert the n into a string. Right? So you just convert it into a string. I think that would be better. Okay. Equals to, sorry, the label equals to a string that looks like this. String. So I have to, okay, that's fine. String label equals, okay, so there's a plot that looks like this. Okay, so this is another way of the string plot label equals, I think it's like this. Okay, so instead of just plotting it as n, of course this one will work, but if you were to convert it into string, I think it also works better. String, yeah, so both will work as well. Now if you want to label it more appropriately, you will say like this. How about if you want to say string, if your label is like n equals to 0, n equals to 1, n equals to 2, instead of just a number like this, so what should you do? So we say, okay, your label has to be n equals to n. So this has to be a string, and then this has to be a number. Then you put it inside here. No, it's not going to work like this, okay? It's not going to work. Now the correct way to do is like this. So what you have to do is that you have to define a string n equals to, okay? So if you do like that, then n equals to will be appeared in the label. So you want to now add in numbers of n. So add in n, which should be a variables, a number, but where are you going to put it in? So the correct way to do this is you have to add it as a string. This means that you append a number, you append a string after the string n equals. Okay, so you just say this is n, but this n must be a string instead of a number. So you just turn it into a string like this. Okay, so then this would be a string that appears as a 0 or 1 or 2, and is to be appended to the string n equals to. So this whole thing is a string. So you just convert the number into a string, then you append the string that represent the number n to the symbol n equals. Then, okay, so the label has to be closed like this. So, okay, so this is the thing that is going to go into the label. This is to close the plot. Okay, the plot here, start here and here. Okay, then you put the legend. That's how you get it. Okay, so this is very useful trick to define a legends in a family of curves. So you have what we call a family of curve. So a family of curve where the family is made of n equals to 0, n equals to 1, 2, 3, 4, 5. So when you have a family of curves and you want to label them in the legends, so you have to assign a variable that change. So this variable that change for the n have to be converted into a string. Then you append the string to the label that you want. Okay, so that is a trick. So we have seen how you can use the special functions. SS, well, the SS will stand for SciSpi.special to plot a special functions. So the next thing we want to do is to generate this function ourselves based on the integration. Okay, so we're going to do this integration using our own methods of integrations. So now in this case, if you want to do the integrated functions, it's a bit more complicated than this case. In this case, you have just a function. It is just a function that emits an argument of x, where this x is the independent variable. But for such a special functions, not only you want to evaluate the values of the function at a particular x, you also have to assign the order, right? So let's see how you do it. So up to this point, if there is any questions from you, am I going too fast, or can you catch up with my my lecture? Now it's 3:56 now. We will take a break for 5 minutes. Maybe we'll come back at say 4:05. So maybe more than 5 minutes. Okay, so 4:05. So we'll come back at 4:05. Then we'll continue. Now before we switch off, any problem? Can I ask now? Participant? No? Okay, if there's no, then we take a break. Okay, so that's for the moment. Fine. Okay, fine. Okay. So let's come back to this part 7. Right. So we are talking about how to generate the Bessel functions. So first of all, we have to define the integration, right? So we have to define the integration. It's a bit complicated, so I have to refer to this formula. It's cos. So let me cut and paste. So the function is to integrate with respect to t, right? So when you look at the integration, you have to be very careful. Let's try to define a function that would integrate this cos nt minus x sine t dt. And when you do the integration, you have to very carefully understand that in the integration, t is the variables. So the integrand is cos bracket nt minus t minus x sine t. And then n is a constant. And x is also a constant. Right? So the integration is with respect to t, but not with respect to n or x. So when you integrate the integrand, you must understand that the integrand variable is t. So let's cut and paste this, and let me try to see how you can do that. Okay, so let me, let us make use of this, panel to do my demonstration. Okay, so I have already imported the Bessel functions, a special function and this, but I don't really need this later on. So I'm going to do this. So I'm going to specify my n to be 0. And let me try to first integrate the functions at the point x equals to 0. So where am I? Okay. Integrating with respect to x equals to 0. So let me try to generate this point by performing the integration. So I expect that when I do the integrations, the answer should be 1. Okay, integrate from, the limit is from 0 to pi, and then the whole integration is to be divided by pi. So let me do this. So my x init should be 0. My x last, well, not to say x last. Now I'm going to define my t init. T init is the function of integration from 0, and then t last is np dot pi. Okay, so this t init, t last referring to the integration from 0 to pi with respect to t. Okay, so my integration is to be done performed on t. So I have to then define my integrand. So I call it integrand. I just call this f. This f is going to read in an integrand. The integrand independent variable is defined as t. Now be careful, okay? T and x has to be distinguished from each other. The t is the independent variable in the integrand, not the values of x that enters the argument of a Bessel function. Okay, so let me now construct this. Okay, cos nt blah blah blah. So this integrand function is returned. So the integrand is cos nt. So let me. So it's np because n is a number. Okay, so the n has to be specified to be already n equals to 0, and then multiply with the variable t, and it's going to be minus x multiplied with sine of t. Okay, so here I also have to specify my x. So I have to specify not only n, I have to specify my x to be x init. Okay, so let me cut and paste this one just to make sure that you know what I'm doing. So I have to specify the initial and the last values in the limit of the integration with respect to t. And then we have to specify the n and x explicitly. Then we're going to call this. So we're going to print the values of f and t. Then t is 1. So that is not t. So I'm going to integrate this. So I'm going to say integration, well, I have to, well, I may call it results. Okay, results is defined to be ss dot in ss dot quad, okay, and then I'm going to integrate with respect to t, and the t is going to begin from t init to t last. So when I press button, if everything goes fine, I will see 1, but not yet, because the functions of the integrand has to be divided by 1 over pi, right? So I have to divide this by 1 over pi. So this has to be divided by pi. Okay, so when I press the button, I expect to see the result of the rest is 1. I got an error. So the quad size pi blah blah blah. No, it's wrong, right? This is not cos. Now I'm going to call import size pi dot integrate as si. Okay, so this is the integrate functions from size pi, but I mistakenly typed this as ss, so it should be size pi integrate. So I call si. So si is the integrate function. Do I get 1? Yes, I get 1. So this is the number. Right? This is just the error. So this is not what I want. So in order to restrict my to make my result looks better, I just extract the 0th component in the output array. So that will give me a result of r. Right? Now what happens if you want to specify the values of x at say say what happens to this number? So this is when x equals to 5. When x equals to 5, I should expect the result of 0 minus 0.2. So let me change this to instead of x 5. So I should expect values to be returned as something which is minus 0.2. So I get 0.2 minus 0.2. Yes, I got roughly minus 0.2. So this is the values, which is the values of this point. Okay, it's not exactly minus 0.2, but minus 1.77. Now, what happens if you want to integrate the whole thing, right, from 0 to 20? So if you want to print out all the values of the x from 0 to 20, then you will be in trouble, because the x is defined externally, right? So that would be some trouble. So you can define xlint. So how do you generate a list of number that would return the values of the integration at every xi, right? x1, x2, x3, x4, x5. It would be difficult for you to do so, because in the definitions of the integrations, RES, its value depend on xi here. So it's kind of difficult if you want to do that. So what we do is we are going to learn a new tricks. So if you look at the integrations functions, let me try to add in one point here. So let me try to do a help file, help on the size pi integrate. The help file says this. So the help file size pi integrate says that you can pass an extra argument. Let's see how you do it. Do you have this extra argument thing here? A lot of informations. I think, oh, that might be too much. Maybe not to look at just SI itself, but quad. Okay, I think that is better. Quad. So, okay, this gives you a more specific integration. So, sine span of quad, you can pass the extra informations of quad. Well, this is as complicated as it is sine si quad. Okay, so you have this argument thing. That's what I'm going to show you. So you can pass additional argument to the functions to be integrated. So this is the function, the integrand. So the integrand should contain only one single variable. So in this case, the single variable here is this t. But if you want to, say, add in n and add in x into the functions, you can pass this extra information about the values of n and x into the integrand of sines of quad using this. Okay, so this is possible. So let us do it. So what you do is in your quad function, you just say, okay, your argument comprised of two numbers. So one number is called n, another number is called x. Okay, and what is x and n? This is the values of n and x. So this is an n assigned as 0, x is assigned as 5, and this argument would then goes into the definition of fx. Okay, so let's just try to see if this works. So by doing that, this n equals to 0 and x equals to 5 will be passed into the definitions of the integration into f through here. Now, if you don't have this argument thing, then the values of 0 and 5 would only pass into the definition of fx in a way which is different than the way how you pass it to it. Right? So I just want to make you understand that if you don't do it like this, then n and x would not. Okay, never mind. Let's try to do this. So let's press. Make sure that they have got number that comes out. Okay, so the argument is not defined properly because the fx here should emit an argument. Okay, so now we have already passed the values of n and x into arg. So when you call the quad for the function f, then it will come here. So I think you need to do this. I think if you're not mistaken, you will say, what is your values of n? The values of n that should appear here should be a values of n, which is the first values of the argument. And then the x that should be the values of x that appears inside the definition of function here should be taken from the argument that we pass in, the second element in the argument that pass in. So this is the argument. We have two numbers in this argument, and this argument is passed into here, n equals to 0, n equals to 1. So n equals to the argument 0, x is argument. So that is how you pass the values of n into the function. So let's see if it works. Now if it doesn't work, then we have to further modify it. Okay, it doesn't work. Okay, so the argument has not been defined properly. So it has to be, I think it have to be, I think the argument has to be, okay, let me check this out. It should be args, okay? It should be args, but not arg. Okay, so I have args, I have to be like this. Okay, so maybe not args, I think it's like this. args, argument. Okay, so it doesn't work. I think there's some typo error. arguments, maybe not this args, argument as 0 and 5. Okay, so let me see how I specified it. So the correct way to do this is passing an extra argument. Yeah, I think it's correct. This argument, and then in the args. So I think now I know where the error is. The error is that they have to pass the arguments to here, args. Okay, so this args is being passed into f through this line. So this was assign the values of n and x into the argument of f(args), which in turn will pass into the definition of f. Then when this f function is called, n will be evaluated based on the values of the 0th element in args, and x is a value evaluated as args1. Let's press again. Okay, now I got a number. Okay, so this is a number which is at x equals to 0, n equals to 5. So this is how I obtain the values of the functions when x is 5. Now if x is say 2.5, then I get a different number. Okay, I got a different number. Okay, so now I'm in the positions to generate the values of x, the values of j for all the x from 0 to 20. Now this is how I do it. So this is the functions of j. Okay, and it explicitly depends on n and depend on x. Okay, so now I'm going to remove the x and I'm going to generate an array. This array is to be generated for x in x array. Okay, so x array is not generated, but I'm going to generate my x array. The x array is a number that begins from x in it. Okay, it is called x. This is already been generated. Okay, so this is the x in it, x last, and x is already in the array. So to make things more clearer, I'm not going to call this array as x. I'm going to call this array of x is just called ARR. So just change the name because I am using x here again, right? So I'm going to make the x as an independent variable, and then it's going to take on all the values of x array, right? So x array is an array that is generated by the lin space. Then this for loop will generate values of the Bessel function at x equals to 0 for all the x that is inside the array. So when I press the button, I would see an array which contains many values for the function of j0 from 0 up to 20, and there will be 20, so there will be 50 number for this j. Okay, so let's see if this works. Okay, so yes, it works. So now I am in the position of plotting x array, y array, plt, plot like this. Okay. Okay, some error. Plot plt plot. So the problem is that I have not imported import matplotlib.pyplot. Okay, as plt. So this is the import that I forgot to bring. So pyplot. So it works. No, it doesn't work again. What? Okay, so I think it should be this. So let me throw this away and then display this. Now this is correct. Okay, this is an array of y value, and then I'm going to have x array. So this will be an array of x. This will be array of y, and then I'm going to plot in a bracket. Yeah. So that's how I plot it. And then I may want to assign this to be a plot which is having a label. Label equals to what? Equals to n equals to string str n. Okay, so again, I always keep on doing these stupid mistakes. The label should be correct, but why label plot squad? Okay, let's check this out. The plot, no, yes, this one, no. Okay, so this is plotting. I'm going to find out where should I slot in the argument for the. Okay, so this should be the argument for x. Okay, so I think this is the one. Okay, so the label should appear here. Okay, it should appear in the last argument of the plot. Okay, so I got this label done. Then I should get a legend. Okay, so I should say plt.legend. Like this, legends with an x, okay, without an s. Legend without an s. Okay, so I have a legend, n equals to 0 is here. So now, what happens if you want to add in more n? Okay, so what do you do? Any idea how do you want to modify the code so that you add in, say, n equals to 1, right? So that you can reproduce the code for this for n equals to 1 and n equals to 2. So what you do is just add in one more layer. Okay, so let's look at here. So this is the plot for one layer. Maybe I'll call this, you know what, let me call this, not sure if this is working, must say dummy. I just call it dummy. Dummy equals to this, plot legend. Wait, I make people come in. Okay. Okay, fine. So someone is responding to me. T init. Okay, never mind. T init. Okay, so T. Yeah. Okay, so there's the error. So okay, fine. I think it works. And T init. So I corrected this one. Now, so it's working. So I just want to add in one more line. So the dummy is a dummy with n equals to 0. So what happens if I do like this? Dummy for n in n space. Okay, so in a range from 0 up to say 2. So that I get three Bessel function from 0 to 1 to 2, and I close it in this. So would I be able to get things shown properly by doing this? It doesn't work. No, because I use a range. I always use a range incorrectly. So n in range 2, no, num a range again is not. Okay, stupid. A, just range. Okay. Yeah, no, it doesn't show. Oh, bad. Okay, so it doesn't show for some reasons. Plot legend, maybe PLT show. Does it show properly? No, it doesn't show properly. So it looks like this is not the correct way. So the dummy does not encode this. So what I do is I'm going to cut the whole thing, call it dummy, and then I'm going to ask it to show in an array. See if it works. Okay, now it works. It works for n equals to 0 and 1. So now let me show this. So n is not going to be range in 0 and 1, 2. So I'm going to make this to be, say, 7, so that it shows a total of 6 lines. Yeah. So it shows those 6 lines. So that's how I construct a family of Bessel function integration. So you learn from this very simple exercise how you would perform an integrations using x squared by passing extra argument, right? So the extra argument is to be, let me show how to do this, okay? So the extra argument to pass is that in order to obtain that, in order to do that, you pass the extra parameter and an x into the definition of the integrations through this additional argument. Right? Then you also have to define in your f here with the argument, where this argument is an array or a list, and then you define your n and define your x from the argument that is passed into f. Then using the n and x here, then only you define the integrants. Okay, so that is it. That is the way how we perform these integrations from using this argument. Okay, so this finishes the part on generating the integration. So in this case, it's quite complicated, right? So you have to integrate the Bessel function at one fixed point of x. Then you have to make x equals to 1, 2, 3, 4, and then you plot all the values of the function evaluated at different x, then join them up. And on top of that, I also want you to show the additional order, and then you plot all the function on the order. I think in your assignment, you have one such exercise to do. Let's see what is your exercise. So your exercise is here. If I'm not mistaken, you can check on your exercise. Let's go back to the exercise and see. Okay, this one. You can click on your assignment. So I just want to show you what you are supposed to do in your assignment. You have 1 week to complete the assignment. Assignment 7. Okay, your assignment 7. Okay, so you are going to do this. Okay, so you're going to do this integration. No, this one, the gamma function. So instead of generating the functions for the Bessel function has 2 additional parameters, right? So in the Bessel function, you have to specify the order, and then you have to specify the values of x. So in this sense, the integration is with respect to tau. Additional parameter is n and x for a Bessel function. In your assignment is this one. Okay, your assignment is to integrate over the values variable of x, and then you have only one independent parameter, which is your x. So you are asked to generate the gamma functions and show the numerical values of it using both the built-in function, math gamma, or special gamma. So now you look at these special functions in SciSpi. You can actually find gamma function. Find gamma. Where is the gamma function? Okay, so you can use the gamma function, gamma, in the special function, or according to the exercise here, you can also try to obtain the gamma function value from the math, math package. So gamma function is defined both in SciSpi, in the SciSpi special, as well as in the in the math package. So either one will do. So you use the math package or the special function in SciSpi to generate the values of the gamma function. Okay, so I think there is some yeah, so this is not this is the x. I think this is not really that functions, is it? The gamma function, integrand. Okay, so maybe I think there's some slight mistakes in my questions. I think I missed one more point. So these integrations, you are supposed to show the integrand. So this is the integrand for different x. Then you're supposed to show the values of the integrands for this. Maybe this is fine. Maybe purposely you're supposedly to generate and then generate the gamma function and display the gamma function. But this question does not ask you to display the gamma function, so I think that is fine. You only ask to perform the gamma function for 3 values instead of plotting the real gamma function. But the question would be quite complicated for this. So you are going to do this incomplete elliptic integral of the second kind. Now, in a way, this incomplete elliptic integral of the second kind is a special function, which is, well, structurally quite similar to the Bessel function. Here, you have this integrand, where the integrand is to integrate. I think there's also another problem. I think this integration with respect to dt. So I have to correct this. So this is the integration with respect to dt. So the dt is missing, so I'm going to correct this. Then it has 2 parameters, which is phi and m. Okay, so you're supposed to displace the special function called e for different phi. Okay, so for phi equals to 1 pi, half pi, 2 pi, whatever, and then for different values of m. So you're going to show this. So this is not exactly the same as the Bessel function. There are some subtle differences, okay, but not really much differences though. So m is a variable that is going to change continuously. In a way, this is very similar to the Bessel function. It's just that the integrand will look slightly different. Okay, in the Bessel function, the integrand is d tau from 0 to tau. So this is what we call a definite integration, and parameters of n appears inside the argument of the integrand. So is the order of n appears inside the argument of the integrand. But for the exercises, this incomplete elliptic integral, the parameters of phi appears in the limit of the integration. Okay, so this is a subtle difference, but you have to think of a way how to do this. So I'm going to correct this. This is integration with respect to t. Okay, so this is an exercise you expect to do. So we are going to continue with the code, the lectures, which is on double integrations. So double integration is slightly complicated, more involved than the integrations for single variable. So in this case, you have the functions of 2 variables. So in this case, the functions of 2 variables is lambda. So for example, the lambda depends on 2 variables. For example, in this case, your lambda is this. Okay, so for example, in this case, your lambda is x y squared. So the values of the the function, this is called lambda, is called the function of 2 variables. It has variable x as well as y. So in this case, x and y are both independent variable. Its value, that is the value of lambda, depend on both the values of x and y squared. Now this is very similar. This is different from the function of single variable, right? Function of single variable, the values of function of single variable ft depends only on the single variable values of t. Where t equals to 1, then f is some number. T equals to 2, then f is some number. For a function of 2 variables, the functions depend not only on one single variable x, but also depend on y's variable. So for example, x is 1, y is 2, then the function of lambda would be 1 times 2 squared is 4. So if x is different value, y is different value, then the function of lambda would take on different value. So this is called a function of 2 variables. I suppose that many of you are not familiar with function of 2 variables, but it's very important. Okay, so the behavior of the function of 2 variables is a generalization of the function of a single variable. Okay, so when you perform an integration over a function of 2 variables, you have to integrate over y and over x. Okay, so For most of the cases, the function of two variables, when you integrate over the independent variables, x and y, it doesn't really matter whether you integrate over y first or integrate over x first, right? Finally, you should get the same number, right? So this is one of the characteristics you have learned. For those who have gone through vector calculus, ZCE 122, I think most of you have done, still doing it now, I think. So in the vector calculus, you are learning how to perform a two-dimensional integration. So this is very similar to that kind of functions. But in your vector calculus, your integrations is more complicated. In the case of vector calculus, the integrations is a vectorial integrations, whereas the functions of two variables we are going to integrate here is a what we call a scalar integration, right? So it's just the x and y is integrated, from x equals to 0 to x equals to 1, y is to be integrated from 0 to 5, for example. So when you integrate, the values of x just varies linearly from one number to another, y from one number to another number. In your vector calculus, the integrations over x and y would not be so simple. The x could have some kind of trajectory, y would have some kind of trajectory, so that would complicate the matters. But in our case here, the functions of integration, the x is just straightforward from one value to another, y value to another. So the integration path over which x and y is integrated over are always straight line. Okay, so that is a simple situation. But anyway, we are going to learn how you perform integrations. So you have to understand that when you perform integration, you have to first decide whether you want to integrate over the x variable first or the y variable first, because this will have some subtle impact on the way how you define integrations in Python. Okay, so for example, say if you integrate this function over y value first from one limit of y1 to y2. After that, after you have integrated over all the y variables, what happened to this thing in a big bracket is becoming a functions of only x. Right? So after you have integrated over all the y variables, then the integrations results in a function of lambda, which is only a function of, so I think this is an error. So again, there's another error. So this is not lambda, this should be fx. Okay. So once you integrate lambda with respect to y, then we result in a function of fx. So this should be fx, not lambda. I'm going to correct this, and then you will retrieve the corrected versions of the lecture notes later. Okay. Then after you have finished integrating over y, only then you integrate over x. So in this example, you integrate over y, then you integrate over x. Now this is an example. Okay. So you integrate over y, then you result in a function of x over 3. X over 3 is a function that you obtain when you integrate over y. After you have finished over integrating over y, then you integrate over the variable x, then you result in this number. Now you can perform the same integrations by integrate, instead of over y first, you integrate over x first. Right? So you integrate over x, then what you obtain is that after you have integrated over x variables, xy square integrated from x1 to x2 to become 2y squared, right? So this is very simple to understand. The function of two variables, when you integrate over one variable, then it's left as a function of the another independent variables. So either you integrate over the x first, only then dy, or in this case, if you integrate over dy first, only then you integrate over dx, both will give you the same values of 2 over 3. Okay. So we are going to see how you do that integration. So the syntax of doing these double integrations in Python is a bit complicated. So what you have to do first, you have to define your integrand, and then you have to define which is your variable which you are going to integrate first, and which is the variable you are going to integrate later. So in this particular example here, okay, so we are going to integrate over y first. Only then we integrate x. Right? X is obtained, x is integrated over only after when y finish integrating. So in this example, we are going to call y the first variable to be integrated. Y is the second variable to be integrated. Okay, so this would be your y. This would be your x. Okay, because it's going to be integrated later. So we have to make these definitions clear in order to perform the integrations. Okay, so then you have to call the size integrate double what? Now, this is the function you are going to use to perform the integrations. So you are going to call the integrand which you defined, and then you are going to pass the values of the second variables. So in this case, this x1, x2 is to be integrated later. Okay, so the x1, x2, which is the later variable, is passed into integrand. But then what is important is this lambda thing, right? So you have to declare the keyword lambda. Then after declare the keyword lambda, you have to assign the limit of the variable which you are going to integrate first. So in this case, you are going to integrate y1 and y2. Okay, so you have to pass the limit of y1 and y2 to the variable called variable first. So this very first would enters here, whereas the very later would comes in later. Okay, so it might be very confusing to do this, but let me try to reproduce the integrations here. Okay, so let us try this. So we are going to perform this integration, xy squared integrate over y first. Hopefully that by showing you how I define this, you will be able to follow this. Okay, so first of all, you have to import the SI, and then I'm going to define, well, I'm going to define my values of limit. So in this case, we are going to integrate x1 as 0, x2 as 2, right? And then y1 as 0, y2 is, so let me define this value, which is the limit first before I do anything, because this will help me to make my code better. Okay, so here y is the limit where I'm going to integrate first. X is going to be integrated later. Okay, so then I would define my functions. Define my functions called lambda. No, I call it f. Okay, this is an integrand. Well, maybe I just call it integrand. This is an integrand I'm going to integrate over. And then this integrand have to emit two variables. So variable first and variable later. So this variable first and variable is just a name that I use to pass the variable into the definition of the integrand. Okay. Then what is xy squared? So I have to decide what to call x and what to call y. Should I call x as the first variable, or should I call y should I call x as variable first, or should I call x as variable later? Okay, so that depends on which one I want to integrate first. So here I'm going to integrate over y first. So I'm going to call y as the variable that is going to be integrated first. So therefore, this is the variable I'm going to integrate over first. So I'm going to call it y. Okay, y to be variable first. Then after I have assigned y to be the variable to be integrated first, then I'll call x to be the variable that I'm going to integrate later. Okay, so I think this is a trick. Y is to be integrated first. So it's assigned as y first. Then the next it should be y lah. If you assign already y as a variable first, then x of definitely will become this later. Okay, then you return definitions of return x multiplied by y square. Okay, so now I'm going to call my quadrant. I'm going to call the quad si dot not quad QUAD. So it's not going to recall quad, but the double quad. Okay, the double quad will emit two variables. You must emit. You have to tell where is what you want to integrate. So the integrate is an integrand. Integrand. Now once you have defined the name of the functions which you want to integrate over, in this case is integrand, which is already defined, then you have to pass x1, x2, y1, y2 into the integrand. Right? So what you do is that you first have to pass. Now you have to pass the variables you want to integrate first through a keyword called lambda. Okay, lambda. So you say lambda. So lambda is a special keyword that is used by Python. So when you type lambda, you see it become green color. Okay. So lambda, you have to say the lambda for the variable first. Right. So this will say that I'm going to integrate variable first, and the variable integrate this lambda variable first is the values of y equals y1. Okay. Then you also have to pass, after that you pass the variable of y1, then you pass the lambda variable first of y2. I think that is how you pass it. So this is the limit of y1 and y2, which should appear in the integration that you should do this. So y1 is this and y2 is this. Okay, so I think that is how you define the limit of the variable you integrate first. After you have finished defining this, then you come back to this place to assign the other limit. So the rest of the limit should be x1 and x2. Okay, so I think that is how you define it. I think there's also some line that is missing. I think this is lambda with a double dot and then lambda double dot. To make sure that I am correct, let me check. I think this is variable first y1, variable first y2. So that is the correct way to do the integration. Let me press button. I got a syntax error. Okay, why is that? Because the return is like this. I got another error, which is y1, y2. So there should be no comma. Okay, there's a comma, y dot dot. Okay, I think that's this lambda variable first. Now I think lambda should not be separated from this. Lambda is a keyword. Say lambda keyword variable first y1. I think this is what it says. The keyword lambda variable first assign y1, then comma lambda keyword variable first y2. Now these are the syntax that I am not familiar with the syntax, so I keep forgetting. But anyway, you can always look up into the help file. Once you have done much exercises, you should be able to remember this syntax. This is a language, right? So once you use the language more often, you'll be able to understand the syntax and don't make mistake like me. So you got the same number. Okay. So this is how you perform the integrations with respect to x and y. But here you integrate the y first. Right? So when you integrate y first, you call this dy as the first variable. Now, if you understand what I'm doing here, then you should be able to reproduce. Okay, let me say here. Let me cut and paste this. Now, if you understand what I do here, then you should be able to do this. Let's just now try to integrate over x first instead of y. Now, I perform this change here so that you understand the subtlety between how you define the double integrations. So here we are going to integrate x first instead of y. Now finally answer should be the same, okay? So I'm going to integrate x first instead of y. So in this case, the x should be made as the first variable. So when I define my integrations, then the first variable should be then my x, right? Then this should be integrated later. So what is integrated later? So I decide that the variable to be integrated later is y. So I call this y. After that, then I define my functions. So when I integrate, I'm going to integrate over y first. So I'm going to integrate x first. Therefore, the x variable would be, the first variable would be x, limit of it from x1 to x2. So in this case, in the definition of the lambda, the variable that is going to be integrated first would take the limit from x1 to x2. And then this number that appears after the integrand should refer to the variable which is going to be integrated later. Okay, so this should be y1 and y2. Therefore, this should be y1, this should be y2. So that is another way of so this is a code that is meant to integrate the function in this manner. Integrate y first, integrate x first, integrate y later. Then this is a functions that is to integrate x first, integrate y first, don't only integrate y. But anyway, the pattern is more or less the same. So you study this example, then you should be able to perform a double integration. So if you understand this, let's just try to integrate this. So maybe exercise will help a little bit. So I'm going to add this one. So let's see how we're going to do it. So let's just perform this integration. Okay, we're going to integrate x first. So here, let us do this. So we are going to integrate over. We are. Okay, I'm sorry. Sorry, my mother suddenly comes in. So give me a few more minutes. Let us complete this one. Here, let us integrate x first, then integrate y. So here, I'm going to call my first variable to be x, and the second variable to be y. Okay. Then here, my y1 would be 1, and y2 would be 2, x1 would be 3, x2 would be 4. Okay, so I'm going to integrate x first. So this is going to be redefined x multiplied with y plus 2 multiplied x square 2 plus y square 2. Okay, so now I'm going to touch up this part. Now these values of the integrations should refer to the integration that is integrated later. So this should be y1 and this should be y2. So this should be y1, this should be y2. And the lambda would define the values of the integrations that's going to be done first. So this is to be done on the variable x. So the x is to be integrated from x1 to x2. Okay, so this should be x1 and this should be x2. So this is how I define the double integration for this part. Okay, so this answer should be the same as the answer for this one. Okay, so you press the button, you get the answer. So it's 32. If I'm not mistaken, it should be 32.25. Okay, I think this is 22. Yeah, it's correct. So you have two ways to perform the integration. The integration that's performed by this is given by this first integrand, whereas the second integrand is referring to the integration with respect to this one. But when you call it the same. Okay, so you just compare the way how you do it. But when in actual situations, you only need to either define your integration in this manner or in this manner. Either one will do as long as you got the correct number. Okay. So that is the double integrations. But functions of single variable, it's easy to visualize. So when you visualize a function of one variable, this is the y-axis, this is the variable. So the variable will change independently, and the values of y depend on the independent variable. So this is how you visualize a one-dimensional function. Now, if you have two-dimensional functions, the x change independently, y change independently. So the values of function f, sometimes we call this z. The values of z, which is equal to the values of function f, depend on values of x and y. So how would you visualize the function of f when x and y change independently? So you have to use a different method to visualize a function of two variables. So you have to use either the contour plot or match color plot. Right? So you just have to define your function array x and y, then you define your z array. So this z array is the values of the function, right? So the function of z depend on the particular values of x and y. So x and y define a two-dimensional space. In a one-dimensional function, x define only one-dimensional parameter space, a one-dimensional variable space. But for a function of two variables, you have two variables. So therefore, we call a function of two variables to live in a two-dimensional variable space. In order to visualize this, you have to plot this function on a plane, where the plane is defined by x and y. So this is how you do it. Okay, so you do the x and y, then you call the contour plot, then you run it. So this is how you visualize. So if you have a particular function that looks like this, okay, xy plus 2x squared plus y squared, that looks like this, then you define your function of two variables. Then you can get your x to change in this linear space, y to change in this linear space. Then you define the function which is depend on x and y. Then you plot the z value, which is the function of f to d in each values of x and y. Then you obtain this ZRR. Then you'll be able to plot it using this very simple method. Then you visualize the two-dimensional function. You can also visualize a two-dimensional functions using not only contour plot but also density plot. So this is example. Okay, so I have a function of two-dimensional values x and y. And this function is sine times cos. So this is a sinusoidal function in two dimensions. How would you visualize a two-dimensional sinusoidal functions? So this is how you define the two-dimensional functions. Then this is the values. The x is changing from one number to another. This is to change from one number to another, where the x is changing from minus pi to pi. So is y is changing from minus pi to pi. Then you generate this array of the functions for x in this, and then you x in this. So once you have done that, then you can do the contour plot and density plot. When you run it, then you see that the functions of two variables for cos times sine can be visualized in either the density plot or contour plot. Okay, you can also visualize a two-dimensional function using what we call 3D plot. So I'm going to finish it soon. Give me 5 more minutes. Sorry. So okay, so these functions is to be done using this method, very simple method. You just follow this integration, this syntax, then you run it. Then you'll be able to get the plot. So sometimes this contour plot 3D is a bit slow because it involves generating a lot of data point. So I would not go into this in detail. You have to do this your own. So you read through this method and then you plot the graph like this. So this is a way how you visualize a two-dimensional function. So the important point here is that if you're given a two-dimensional function, you either visualize it in terms of a contour plot or a density plot. And this is a way how you do it, using contour plot and supply the values of x and y, and also the functions of z. So you display the values of the function in the contour plot or in density plot. Okay, so in contour plot, the difference is that it line up all the values with the same values. Right? You learn this contour in your geography, right? For those geophysics people, in a potential, in the potential field, you join up all those points that has the same values of potential. Then it somehow will define a boundary. So the contour plot and this density plot are different in the sense that contour plot, it joins up the point with the same value, whereas in the density plot, they don't join up the density, they don't join up the points that has the same value, okay, but more or less the same. You can also visualize a two-dimensional function using a 3D plot that looks like this. Okay. So it depends on your choice of how do you want to visualize a two-dimensional function. So the details of it you can study for yourself. So these are the example. You have to call a matplotlib 3D. You have to use this MPL toolkit, import it, then you plot it. So you have to do a mesh grid in order to generate the function of z. So the way how you use a matplotlib 3D and the contour plot is slightly different. So it's slightly easy to use the contour plot. So just say PLT contour plot F, or just say plot color mesh. So this will call out the contour plot and the density plot. But in order to call out the functions to plot 3D, then you have to use this. You have to use a matplot 3D, and then you have to mesh it, define your z functions, then show it up. Okay, so these are the sample code which I think you can study on your own. Now, once you are familiar with the code, next time if I give you a two-dimensional functions and ask you, okay, please plot this function for me, then you should be able to do that. Okay. So we are over time a little bit. I thought that we could finish it earlier today. Now, the sooner we finish our syllabus, then we can stop earlier as well. Okay. So so next week I'll see you again. Next week, yes, okay. So next week we will have an assignment and a test on Monday. Now, if you encounter any problem, please contact me privately. Either write email to me or just send a message to me or talk to me in the WhatsApp. Now, before we end, is there any question from you? Okay. So if there's no questions, then maybe we can stop here. So attend your assignment. Any questions, just let me know. Okay, so that's all for today's lecture.